Hey everybody, in this video we're going to review some of the circuit annotation rules that we learned in class before you guys went to February break. So as you can see here, I have a series circuit that I'm going to annotate in just a minute. Up top I have the color order that you have to use in order from greatest to least voltage. Red represents the greatest voltage and blue represents the least voltage. And then I also have my two rules written out that I have to follow whenever I'm annotating any one of these circuits. And the first one is to always start with red and to always end with blue. And the second rule is that the voltage drops whenever you pass through a resistor. So you should only be changing color when you pass through a resistor and not at any other time. So I'm going to start annotating the circuit here. And I start with red because that's my rule number one. And notice that I'm starting from the longer line of the battery. That's where we start. That's what we represent as the positive end of the battery. You could even draw a plus sign here if that helps you remember it. And then I'm going to end with blue because that represents the least voltage. And then in the middle of these two resistors, I have to use a different color because the voltage is dropping. So as I go from one side of the resistor to the other, it has to have a different color change aside from red to blue because that represents the battery, and each one of these has to have a smaller voltage than the battery. So if I look at my color order here, I notice that yellow is right in the middle of the whole order and the whole scheme. So I'm going to put yellow in between these two resistors. You could use orange or green if you want, but yellow makes the most sense because it's smack in the middle, but it doesn't really matter that much as long as you're going in order from red, orange, yellow, green, and blue. As long as you're going in this order, it should be fine either way. So now we're going to do a parallel circuit. So I'm going to draw out a parallel circuit here. Just bear with me for a moment. And now I'm going to start annotating for voltage. So same thing, I'm going to start with red on the positive side of the battery. That's the side with the longer line. And I'm going to end with blue on the negative, smaller line of the battery. Maybe that's slightly darker there. I know it's not the straightest line, but just go with me for a moment. So as we cross this point here, it's really important that we notice that we're not actually passing a resistor here. We're still just along the wire for both of these paths. So even though there's a split path, there's no resistor in that path, so we keep that entire thing red. We do the exact same thing on the other side because here, as we pass over both of these paths, there are no other resistors that we're going to pass through for the rest of the circuit. So we're going to use blue for each of these. And this means that each one of these resistors by itself gets the voltage of the battery. So now we're going to move on to current. So to show how current functions in the circuit, we use arrows. And I have my series circuit here that I'm going to annotate for current in just a minute like I did for voltage. But first, I'm going to go over my two rules that I have written on the board. And the first one is that the amount of arrows in equals the amount of arrows out. So this means that if I have 3 arrows coming out of the battery, I have to have 3 arrows going into the battery as well. I know there's a bit of a glare here, but hopefully you can see that all right. And for a second rule here, the arrows split when the wires split. So if I have 2 arrows here approaching a split in the wire, that means that the arrows are also going to split so that if I have 2 arrows going in, one of the arrows goes down one path and one goes down the other path. Notice also that the amount of arrows down these 2 split paths add up to equal the arrows before. So 1 plus 1 is 2. These adding up to equal this is really important. So you got to make sure that you have that. That same principle also applies when the arrows that originally split are coming back together again. So if you have 2 arrows coming in from 2 different paths that are combining into one path, they have to add together to equal 2 arrows going down this path after they merge. So now I'm going to demonstrate this on a series circuit. So here, because there is just one path from one end of the battery to the other, I'm just going to do one arrow going around on each side. And notice here I have 2 arrows drawn kind of next to each other, front to back. That doesn't mean anything in terms of the amount of current. It's just whether the arrows are next to each other that you want to focus on. So here I just have the same current everywhere, so I just draw one arrow everywhere. I could also represent the same circuit by drawing 2 arrows in on each side. So however many arrows are at one point, you could do 3 or 5, even though that would get a little messy if you tried to draw that. But the main point, the main thing you want to pay attention to is the fact that the amount of arrows on each side should be the same. The amount of arrows stacked up next to each other should be the same for a series circuit, no matter how many light bulbs are in the circuit. So now I'm going to go over a parallel circuit. So again, just bear with me while I erase this and then redraw it. There we go. So here in a parallel circuit, I have one split in the wire, and I always have to have as many arrows starting off as there are different paths at the beginning. So if there's 2 paths here, I know I have to start with at least 2 arrows on the side of the battery. Then as I go around this corner, there's no split in the path, so the amount of arrows stays the same. Remember rule number 2. The arrows split when the wire split. But if there's not a split in the wire, the amount of arrows isn't going to change, right? So now at this point, we encounter our first split in the wire, so we have 1 arrow going down here, and then 1 arrow going down here. So this arrow and this arrow, each having 1, add up to equal 2, the amount that came before the split. So then around this corner, once again, it's just one path. The amount of paths isn't changing here. There's no split in the wire here. And then now I'm coming to a point where my 2 different paths are coming together again. So that means that as I go along here, I need to have 2 arrows instead of 1, because they're rejoining, so the amount of arrows after they rejoin has to equal the total of what was going into that, right? Now we come back to the battery, and we have 2 arrows going into the battery again. So that's it. Hope this video was helpful and that you now understand the basics of using arrows to annotate current and colors to annotate voltage.